Swayam Prabha. Digital India. Educated India.
So, in my previous lecture, I solved one numerical problem and found out that the retaining wall was safe against sliding and overturning moment, but there was a known tension zone developed. So, now that is not recommended. So, we have to revise that design or revise the dimension. So, this was the problem, and then we observed that it was safe against sliding, it was safe against overturning, but it was there was a no tension zone was developed. Okay. So, our condition there should not be any tension zone, no tension zone, but tension zone was developed at the base of the footing, because your E value is greater than 0.6, that is B by 6. So, that means we will revise this design, because our aim is should be in such that the below the footing, this should be the reaction, that is the maximum. Okay, that is maximum. So, you can say this is our Q max and this is Q mean. So, this is maximum we should say. So, how we can determine the Q max, Q mean? Q max or mean is equal to summation of all vertical forces divided by width of the footing. Here width is this one, then 1 plus minus 6 E B. So, that is why if it is greater than E is greater than B by 6, then there will be a negative stress. So, that is not recommended. So, this can be 0, minimum Q minimum can be 0, but cannot be the negative, because we are not recommending any design where the negative stress is developed. Okay. So, that is why that your E should not be greater than B by 6. So, now we will take our new dimension. So, let us quickly do the same problem with a new dimension. So, in the second trial, I have taken a dimension where this is the B is 5 meter and the top portion is 3 meter, and rest of the things are same. Okay. Water table or water at the sea side and the backfill side was the same at 5 meter. The height of the retaining wall is 6 meter. So, the same angle, same psi value will be there. So, this is again it will be 80 point, what is the value? It was 80.54 and beta is 9.6. So, the same. So, this is 80.54 and beta value is 9.6 meter. So, we are keeping that part same. So, that means this is 3 meter, this is 1 meter and this is also 1 meter. Okay. So, it is a horizontal backfill. Now, all the other properties are same. So, now here I will calculate our new W, because W will act here and there will be kh into W. Kh value will also remain same. So, W will be how much? Half into 1 into 6 into 24 same into 2, because 2 triangles, plus this rectangle which is now 3 into 6 into 24. So, the new W value is 576 kilonewton per meter. But other forces will not change, only the W will change and KHW will change. So, KHW, that is 57.6 kilonewton per meter. So, the summation of all vertical forces, that is 576 plus the vertical component of PAE, which is 43.4, which is 43.4. So, that is equal to 619.4 kilonewton per meter. So, summation of all horizontal forces, now that is 56.3 plus 184 plus 2 into 14.6, 14.6 plus now 57.6 minus 125. Okay. So, now it is 202.1 kilonewton per meter. So, this is the only change. Okay. So, now I will again calculate the, obviously the, as it was the sliding was factor safety of sliding was safe against 3.5 meter width. So, definitely it will be safe here also. So, no need to check. Okay. Even the your factor of safety for overturning moment, overturning, that will also be safe here. But still we need to know the MR and MO, because we are calculating the E value. So, MR will be now 576 into, now it is 2.5, 2.5 plus again this is the position of PAE. So, this vertical thing that will act again here, and that distance will not change, because we have not changed those angles. So, this will be 0.5 meter again. So, now this is the vertical component is 43.4, because that has not changed. Now, it is 5 minus 0.5, okay, then plus 125 into 1.7, okay, like the previous case that we have solved. So, now it is 1847.8 kilonewton meter per meter. Okay. So, now the overturning moment, that will be 56.3, again 2.98, that is the H bar, then plus 14.6 into 2, and 2 forces are acting, that is why 2, plus 184 hydrostatic force into 1.7. Now, plus now this KH part. Now, again this H bar will change. Initially it was, how much the H bar was? H bar was 2.6, small H bar. Now, again it will, we have to calculate that H bar, and that the similar way you can calculate, and the H bar, new H bar value is equal to, your new H bar value is again half into 1 into 6 into, that is 6 by 3, again 2 plus this portion, there will be change 3 into 6, and then rectangle 6 by 2. Now, divided by the total area, that is half into 1 into 6 into 2 because 2 triangles plus 3 into 6. So, h bar now is 2.75 meter. So, that this is your h bar is 2.75 meter. Okay, so now this horizontal component, that is this kh into w, which is 57.6 into the h bar, because now we are taking again with respect to toe, into 2.75. Okay, so MO value will be equal to 697.4 kilonewton per meter, kilonewton meter per meter. So, again obviously it will be safe against the overturning, because it was safe initially. So, now we are only checking the E value. So, x bar is again your summation of MR minus summation of MO divided by all vertical forces. So, it is equal to now 1,847.8 minus 697.4 divided by all vertical forces is 619.4. So, it is coming out to be 1.86 meter. So, initially it was in previous dimension it was 0.843 meter. Now, it is 1.86. So, E will be B by 2 minus x bar. Now, B by 2 will be 2.5 minus 1.86. So, it is coming out to be 0.64. 0.64 meter, which is less than B by 6, or now it is 5 by 6. So, 5 by 6 it will be 0.83 meter. Okay. So, now it is okay. Now, I can calculate the Q max. Okay. So, Q max I have given the expression. So, this is summation of V by B 1 plus 6E by B. So, V is 619.4, B is 5 meter, then 1 plus 6 into 0.64, E value is 0.64 divided by 5. So, this value is coming out to be 219 kilonewton per meter square, and our allowable value was Q allowable base soil is 250 kilonewton per meter square. So, it is less than 250 kilonewton per meter square. So, okay, it is safe. So, I have taken this dimension. But you can try with another dimension and check you can further make the design more economical or not, because here it is safe, but you can slightly change it and then you can try for another trial and you can make the design more economical, or you can make try with 4.5 meter base and you can try it. Okay, but this is okay. So, that is the process by which we can increase the dimension, and so that we can satisfy all the conditions. Okay. So, and similarly Q mean also been calculated. So, similar way it will be only minus. So, that is coming out 29 kilonewton per meter square. Okay. So, there is no tension zone as it is seen from here, that is less than B by 6. Okay. That means we have to do these 4 checks and then this design is been done. So, now I will discuss our next topic. So, that is your seismic displacement of a retaining wall. Okay. So, in my previous lecture on seismic slope stability analysis, there also we determine that the seismic displacement of the slope of that soil mass or the sliding mass. Okay. So, here also we will discuss about the seismic displacement of the retaining wall. Okay. There are number of methods available, but I will discuss only one method, and that is Richard and Elm method. Richard's Elm methods. Elm's method. Richard's Elm's method that was proposed in 1979. Okay. So, here also the concept of Newmark sliding block analysis is being used, and the displacement, permanent displacement or the lateral displacement is been, the equation is been given. Okay. So, that means here used sliding block analysis concept. Okay. So, now if I take the retaining wall, say this is the retaining wall, and we want to determine the displacement. So, here again the water is not considered. It is the first case that I have discussed. If you want to consider the water, then this you have to do the analysis in that way. But here it is proposed for this without water condition. So, that's why I have not considered the water or pore water effect. So, this is PAE and this angle is delta. So, obviously, this is beta. Which angle is beta? This angle is beta. Beta is the inclination of the wall with vertical. So, this will be your cos delta plus beta, and it has vertical component also. This will be PAE sin delta plus beta. Clear? And here also we, as the weight is significant amount, so we cannot neglect the inertial force. Okay. If the weight is not that much, then you can neglect the inertial force, because that effect will not be significant. But here this inertial force effect is being considered. So, that is again FH, which is KH into W, but that vertical component is being neglected. Okay. So, now here also there will be F or T, and this force will be N. Okay. So, here the level of acceleration is just large enough to cause the wall to slide on its base. So, that means the acceleration is equal to yield acceleration. So, we can write the level of acceleration is just enough, large enough to cause the wall to slide on its base. That is, the acceleration is yield acceleration. Okay. So, now that means our AH is equal to AY. The acceleration that is applied, that is equal to yield acceleration, because my factor of safety is 1 and it will initiate the sliding on its base. Okay. So, now we can calculate that F is equal to this horizontal force, that will be your KHW plus PAE cos delta plus beta. These are the two horizontal component, and N will be equal to W plus PAE sin delta plus beta. Okay. Now, I can write that your friction angle between the wall and the base. So, I can write that your KHW plus PAE cos del plus beta, that is F, that will be equal to, okay, just for your when the factor of safety is equal to 1, that will be equal to N into tan phi or tan beta tan delta W plus PAE sin delta plus beta into tan phi b or delta. This is phi b. The friction angle, what is phi b? Phi b or delta b or delta b is the friction angle between the wall and the base soil. Clear? So, because your F will be equal to N tan phi b or delta b, that is why it is been written. Now, FH, I can write what is FH, KH, you know that KH is equal to AH divided by G, that we know. Now, our AH is AY by G, so that is yield acceleration. So, now I can write that AY divided by G into W plus PAE cos delta plus beta, that will be equal to W plus PAE sin delta plus beta into tan phi b. Okay. Now, if I multiply W with tan phi b plus your PAE into sin delta plus beta into tan phi b or delta b. And if I simplify these things, and finally I can write that yield acceleration divided by G, that will be equal to, this WW will cancel. So, this is tan phi b, okay, then minus this, if I take this PA cos delta plus beta in the right side, so this will be minus. So, and then I can write PAE cos delta plus beta this side, then this is also minus plus minus, this will be minus PAE sin delta plus beta into tan phi b. Okay. So, it is, and then this whole thing will be divided by the W, because it is AYG by into W. So, I have taken this is this side P cos PAE cos delta plus beta minus this one, then divided by the W. Okay, this will be tan phi b, there will be W, and this is the value. So, finally, I can write that my yield acceleration is tan phi b minus PAE cos delta plus beta minus PAE sin delta plus beta into tan phi b or delta b divided by W into G. So, based on that, so from this equation I will get the yield acceleration of this particular system where your factor of safety is exactly 1. Now, from there, using that sliding block analysis, the permanent displacement of course lateral of the wall can be determined by D permanent, which is equal to 0.087 Vmax square Amax cube divided by AY to the power 4. Remember, this equation is valid when this ratio is greater than 0.3. So, you know the Vmax is the peak velocity, Amax is the peak acceleration or maximum acceleration, and AY is the yield acceleration. Okay? So, your Vmax is the peak velocity, generally you take it centimeter per second. Okay? So, this if it is centimeter per second, you will find this will be centimeter in terms of centimeter. And then your AY is, you can see this is yield acceleration. This is yield acceleration, and Amax is the maximum acceleration or peak horizontal acceleration. Okay? Peak acceleration, and of course, it is horizontal acceleration, PHA, peak horizontal acceleration. Okay. So, this way we can determine the values. Now, let us solve one problem, example problem, and we will find that how we will determine the this displacement, permanent displacement. If I take the same problem that I solved just now, I mean same dimension, a problem is different, but same dimension, because that water is not present, but I am taking the same dimension. Okay? So, I am taking the same dimension, which was the final dimension. Okay? This was 5 meter, this was 3 meter, this is 1 meter, this is 1 meter. So, again the beta value will be 9.6 degree, and this is 3 meter, and height is 6 meter. Okay? So, your unit value is taken as 18 kilonewton per meter cube, because only one unit weight, and unit weight of concrete 24 kilonewton per meter cube. Then phi fill is taken as 35 degree, delta is taken as 28 degree, and kh is taken as 0.2, again kV is equal to 0. Okay, and beta is obviously 9.6. Now this first we have to calculate the yield acceleration, and A max I am taking the same value that I took during that example where we determine that slope, that sliding mass displacement. So that value was taken 0.45 g. So same value I will take here 0.45 g. Okay, then kh value, if it is 0.45 g, then kh value should be around, as I mentioned, half of that. So it will be 0.225. Okay, but I have taken 0.2. V max is 38 centimeter per second. Same site response I have taken that I have shown in that example problem. Now calculate what will be the displacement of this wall, lateral displacement. Okay. Now the phi base for base soil, this is base soil, that is 37 degree. Okay. Base soil, and this one is I is also 0. So this is the field soil. Or backfill. Clear? So base soil, this is phi base. Similarly, phi b or delta b, that is again 33.3 degree. Okay, so then now I have to determine what is the value of delta, okay, or D permanent. So what is the value of D permanent in this case? So one thing you remember that if you want to determine the yield acceleration, you need to know that PAE, because I don't know what is the yield acceleration, because I need to know the PAE. Even in the PAE expression, that is, you need the acceleration, because you need that acceleration, because that is your kh, you need kh actually. So from that kh, you need the acceleration. So but unless you don't know the ay, how can you determine the PAE? Because there also you need the acceleration. So that's why it is an iterative process. So in the next class, I will solve this problem and show you how we can determine the yield acceleration by iterative process, and from that yield acceleration, using the other values, I will determine the permanent displacement of the wall. Thank you.